We're using another law today, the law of sines. It too is a way to find missing sides or missing angles of a triangle, just like the law of cosine is. So by the end of this chapter, you're going to have two ways to find the missing sides. And they're obviously going to test you on, well, which way do you use? Because both methods don't always work. So let's just get down to the law of sines. It's rather easy. It's a proportion. Remember, a proportion is one fraction equaling another fraction. And where are these fractions obtained? Well, they're from the triangle. This says that the side of any triangle compared to the sine of its corresponding angle is the same proportion as another side compared to the sine of its corresponding angle. And technically, this would happen again because there are three sides in a triangle. But when we're solving a proportion, we only have one equal sign. So that's why we don't need to worry about the third side. We only need two sides and one angle, or two angles and one side, to solve our problem. All right, here's the problem. All right, we have a triangle here, and we have two angles, a side, and a missing side. Obviously, it's the law of sines. We're in that section. So the law of sines says, take a side. All right, I'm going to take 12, and I'm going to compare it to the angle opposite it. Now, based on the law of sines, any other side of the triangle will be compared to the sine of its corresponding angle. And there's our proportion. We solve a proportion by cross-multiplying. B sine of 45 equals 12 sine of 120. Divide both sides by the sine of 45. And there, that's what side B is. But notice we have this find the exact measure of side B. Anytime it says exact measure, pretty much means they want you to look back at your unit circle. So when I start doing the sine of 120 and the sine of 45, I must use their exact answers and not their decimal approximations. So 12, the sine of 120. Well, sine of 120 means its reference angle is 60. So the sine of 120 is radical 3 over 2 all over the sine of 45, and the sine of 45 is radical 2 over 2. I'm going to flip and multiply because that's how I divide. Let's see, the 2's are going to cancel out, which gives me 12 radical 3 over radical 2. I have to rationalize. Now we're just doing algebra. We're done with law of sines. So I get 12 radical 6 over 2. So my answer is 6 radical 6. That is my exact answer. All right, find to the nearest tenth the area of triangle ABC, where A is 12, B is 15, measure of angle B is 35. Well, first things I like is find to the nearest tenth. That makes me happy. That's all calculator work. I don't need to do my unit circle. Area of a triangle? Wait, I thought we were doing law of sines today. All right. So area of a triangle, I have to bring out my two weapons. Heron's formula and the area of a triangle based on the sine. Okay, so I've got my picture down here. Well, Heron's formula is out of the question, because Heron's formula, I need to know all three sides, and I only know two of my sides. Heron's formula, I need to know 1, 2, 3 sides. Okay, so let's get rid of Heron's formula. I guess that leaves me with my traditional area problem. 1/2 side. Okay, I got a side, 12. Side, I got another side, 15. But sine of the included angle. I would need to know this angle C in order to finish this problem. And this, boys and girls, is a traditional Regents question because they get to test you on two topics at once. Do you know how to find the area of a triangle? And do you know how to find missing angles? So I have to take a sidestep. This is where law of sines comes in. All right, law of sines. 15 side is to the sine of angle 35, as 12 is to the sine of A. That still doesn't get me the sine of C. I need C. I need angle C. Oh, no biggie. If I find out how big A is, then I can just add up to 180 and subtract to find my third angle. Little tricky, Regents, but not that hard. We can handle it. 12 sine of 35 equals 15 sine of A, cross multiply, divide by 15. And I love this part. This is all calculator work. 12 sine 35 divided by 15. All right, means the sine of my angle A is 0.4588611,491. All right, I'm going to inverse sine that because I got to find my angle. Now here again, don't be rounding fools. The answer is 27.31364392. That's my angle. You know what? I'm going to take that angle and I'm going to store it to my x value on my calculator. Why? Because I have to use that to find my angle C. 180 minus 35 minus 27.31364. We want to take a good amount of that number because we don't want to be rounding and rounding and then our final answer will be off. So 180 minus 35 minus x, because I stored it there. That's how big angle C is. Angle C is 117.68635. All right. I'm running out of room here. $6863561. All right. Let's erase this and let's finally get to the area. 1/2 12 times 15 times the sine of 117.6863561, but we've stored that. We're going to store that answer to x now. All right, 0.5 times 12 times 15 times the sine of x, where I stored my answer. There we go. Finally, the area of this triangle is 79.7, because that's where I can finally round to the nearest tenth. I can't keep rounding within my problem. I round at the end.